Welding is a familiar industrial operation that may involve various types of equipment. Some welding applications use electric arc or resistance welding equipment to generate the high heat necessary to fuse or cut metal. But this unit focuses on a different type of welding, oxy-fuel gas welding. Oxy-fuel gas welding rigs or units are typically self-contained, so they can be used in remote locations where there is no electricity. Also, oxy-fuel gas welding rigs are generally lighter and more compact than other types of welding equipment, so they are easy to move from place to place. Operating an oxy-fuel gas welding rig is relatively simple, as long as you have a basic understanding of the components and procedures. Oxy-fuel gas welding is a process that mixes a fuel gas, such as acetylene, with pure oxygen to produce a flame that is used to join or cut metal. Four common applications of the oxy-fuel gas welding process are welding, brazing, soldering, and cutting. Welding, the first oxy-fuel gas welding application we'll look at, is a fusion process that uses a gas flame from a torch to melt metal surfaces for the purpose of joining them. The metals fuse together as they become molten. They are strengthened at the joint by melting additional metal called filler rod or consumable rod. Because welding requires melting base metals, the torch flame temperature must reach the melting point of the metals being welded. Brazing is similar to welding. However, although brazing heats the metal pieces that are being joined, it doesn't melt them. The filler rod, which does melt, forms a strong bond between the base metals. The torch flame temperature for brazing operations ranges from 800 degrees Fahrenheit up to the melting point of the metals being brazed. The melting point of the filler rod must therefore be below the melting point of the base metals, but above 800 degrees Fahrenheit. Soldering is a term that's often used interchangeably with brazing. However, soldering applications are applications that use torch flame temperatures below 800 degrees Fahrenheit. This means that the melting point of the filler rod used in soldering must be below both the melting point of the base metals and below 800 degrees Fahrenheit. Some soldering applications use specific metals as filler rods. For example, silver solder is used as the filler rod in silver soldering applications. As the solder material contacts the heated base metals, the solder melts, pours into the seam, and hardens to form a bond. The last application we'll look at is cutting. Instead of joining metal pieces together, as in welding, brazing, and soldering, cutting burns metal pieces apart. Cutting requires a different torch and tip than the other applications. Cuts are made by heating the base metal and then depressing a lever on the torch handle to release a jet of pure oxygen, called an oxygen blast. The blast causes the metal to burn or oxidize and separate. Oxy-fuel gas welding burns a mixture of oxygen and a fuel gas to produce a high-temperature flame. Oxygen is a colorless, odorless, tasteless gas that readily supports combustion. It is stored in steel cylinders under pressures of more than 2,000 pounds per square inch. To minimize the chance of a fire or an explosion, oxygen should always be stored and used away from flammable materials. Oil, grease, and other petroleum products are highly combustible in the presence of oxygen. Even oil residue or a spark could trigger an explosion. Many different types of fuel gases can be combined with oxygen in oxy-fuel gas welding, but one of the most common is acetylene. We'll use acetylene for the examples in this program. Acetylene is a compound of carbon and hydrogen that has a strong garlic-like odor. In its gaseous form, acetylene is extremely unstable and it explodes easily. For this reason, it's stored in steel cylinders at pressures between 200 and 240 pounds per square inch. Storing acetylene at higher pressures causes a chemical breakdown, which produces heat and pressure that could cause an explosion. Acetylene is generally the preferred combustible gas for oxy-fuel gas welding because its high flame temperature, approximately 6,000 degrees Fahrenheit, is above the melting point of all commercial metals. The high temperatures produced by combining oxygen and acetylene offer the rapid localized melting that's necessary for a variety of welding and cutting applications. As with any industrial operation involving compressed gas or high heat, there are a number of safety concerns and precautions associated with oxy-fuel gas welding. In this part, we'll see some personal protective equipment that's commonly used for welding operations. We'll also look at ways to protect personnel in the work area and ways to prevent fires and explosions. Working with the extreme heat, sparks, and molten metal produced during welding operations presents potential hazards for skin, eyes, and hair. The proper personal protective equipment should be worn to avoid injury. Wear approved, snug-fitting safety goggles to protect your eyes from sparks, heat, and light. Generally, a number 5 or 6 filter lens provides an adequate shield. Wear gauntlet-type leather welding gloves that cover your wrists and hands. Approved high-top boots with steel toes are the correct choice for footwear. Make sure that they are leather and that they fit tightly around the ankles so sparks can't become trapped inside. Wear long pants without cuffs, since cuffs can catch sparks. A long-sleeve shirt buttoned at the cuffs provides coverage for your arms and torso. Clothing made from approved flame-retardant materials and natural fabrics such as cotton or wool provides the greatest protection from sparks and flames. Wear a hard hat to protect your hair and scalp from sparks and molten metal, particularly if you're performing overhead work. When you're performing cutting operations or working in confined spaces, a face shield should be added to your personal protective equipment. To protect personnel working around a welding operation, it's good practice to give advance notice of when and where welding will be taking place. It may also be necessary to erect temporary barricades or shields. Welding operations produce fumes that can cause physical effects, ranging from nausea to serious lung damage if they are inhaled. To protect personnel from the harmful effects of fumes, a well-ventilated work area is critical. A good ventilating system is needed to circulate the air and vent fumes away from the work area to the outside if possible. The potential for fire and explosion is regularly present during welding operations. In some cases, a fire watch may be assigned to watch for a fire and be prepared to extinguish it. You can minimize the chances of fires and explosions in the work environment with a few simple precautions. Never use intense heat or flames in prohibited areas. Be certain that whatever you are welding doesn't contain any flammable materials. Ask a supervisor for a material safety data sheet or MSDS if you are unsure. It's also a good idea to test the air for the presence of flammable vapors. Check the safety and welding procedures at your plant for information on what tests are required, how they are conducted, and what to do if flammable vapors are detected. Additionally, some jobs require obtaining a hot work permit as a precaution against fires and explosions. Check with a supervisor to find out which jobs your facility requires a hot work permit for. When you're welding, always keep the flame clear of other equipment in the area. When you're cutting materials, direct molten metal away from equipment. Erect a shield or use a certified fire blanket if necessary. The oxygen and acetylene used in oxy-fuel gas welding are under extreme pressure. If they are mishandled, explosions could result. Keep compressed gas cylinders away from open flames when you're working with them. Store cylinders upright, secure them, and keep them away from heat sources. Heat increases the pressure in a cylinder by expanding the gas inside. The safety plugs on cylinders can soften and burst in extreme heat, allowing gas to escape. Worse, a heat-related rupture could detonate the cylinder like a bomb. Be sure to handle any compressed gas cylinder carefully. If a valve breaks off or its wall ruptures, the cylinder could launch like a rocket. Cylinders must be inspected and tested every 5 years to ensure that they remain in compliance with Department of Transportation safety standards and regulations. To avoid the chance of workers confusing oxygen and acetylene with each other, manufacturers typically mark cylinders for easy identification. Color codes are often used. For example, this green cylinder contains oxygen, and this black cylinder contains acetylene. However, no universal standard exists for color coding, so compressed gas cylinders are also labeled. Always check the label to determine what gas the cylinder contains. In this topic, we examined 4 common oxy-fuel gas welding applications. We looked at characteristics of oxygen and acetylene, and we examined general safety concerns and precautions associated with oxy-fuel gas welding. Now is a good time to try some practice questions. In this part, we'll look at a main component of oxy-fuel gas welding rigs, the compressed gas cylinders. These cylinders, which are typically made of steel, are used to store oxygen and acetylene. Oxygen, which is stable in gaseous form, is stored in hollow cylinders or bottles at pressures over 2,000 pounds per square inch, or psi. Cylinders containing oxygen range in size from 40 cubic feet to 300 cubic feet. Acetylene cylinders differ from oxygen cylinders in some ways. As a gas, acetylene is unstable and it could explode. For this reason, acetylene is stored in specially constructed cylinders. These cylinders are lined with a porous material that is soaked with liquid acetone to absorb some of the acetylene and help to make it more stable. To keep the liquid acetone from flowing into and clogging valves, it's important to keep acetylene cylinders in an upright position. If an acetylene cylinder tips over, set it upright and let it stand for a specified period of time, typically 30 minutes, before using it. This will drain the liquid acetone out of the valves and clear them for use. Both acetylene cylinders and oxygen cylinders should be chained in an upright position during use or storage and when they are being transported on a handcart. This prevents the cylinders from falling over and being damaged. Cylinders may be color-coded, like this one, and they are always labeled with the name of the gas. For both oxygen and acetylene cylinders, a valve at the top of the cylinder is used to control the gas flow. The valve on this oxygen cylinder has a safety relief device that allows for emergency release of oxygen if the pressure inside the cylinder gets too high. Acetylene cylinders have 2 or more safety fuse plugs, which are generally located at the cylinder's top and bottom. If a fire occurs, the safety fuse plugs release the gas to prevent an explosion. Always handle compressed gas cylinders carefully. Because they are under high pressure, don't jostle them or expose them to extreme heat. Oxygen and acetylene cylinders should be kept secured and upright in separate storage areas. Storing them together, even when they're empty, could cause a fire or an explosion. For example, if gas escapes from a broken or leaking valve on an acetylene cylinder stored near an oxygen cylinder and ignites, it will cause the gas in the oxygen cylinder to expand. Eventually, the safety relief device will open and release the oxygen into the air. There it will be combined with the escaped acetylene to create a highly explosive mixture. The oxygen and acetylene used in oxy-fuel gas welding are contained in cylinders. Valves on the cylinders are open to release the gases. Attached to each of these valves is a device called a regulator. The regulator reduces the high cylinder pressure to the lower working pressure that's required for welding applications. The regulator can also be set to maintain a steady flow of gas from the cylinder. This pressure adjusting screw is what controls the gas pressure. A clockwise turn increases the flow of gas, while a counterclockwise turn reduces or stops the flow. A compressed gas cylinder regulator has 2 gauges, a high pressure gauge that indicates the storage pressure inside the cylinder, and a low pressure gauge that indicates the working pressure of the gas. An oxygen regulator's high pressure gauge typically shows pressures up to 4,000 psi. A second scale on the high pressure gauge gives a metric measurement of pressure in kilopascals or kPa. This oxygen regulator's low pressure gauge shows pressures up to 200 psi. Oxygen regulators, which are often color-coded green, have right-hand threads on the connections that attach to valves and hoses. To install regulators with right-hand thread connections, turn them to the right. To remove them, turn them to the left. Acetylene regulators, which are often color-coded red, have left-hand threads on all connections. A V-notch is cut into the connector nut as a reminder of the left-hand threads. To install regulators with left-hand thread connections, turn them to the left. To remove them, turn them to the right. An acetylene regulator's high pressure gauge generally shows pressures up to 400 psi. This acetylene regulator's low pressure gauge shows pressures up to 30 psi, but it is redlined at 15 psi, which is the value that acetylene pressure should not exceed. There is a second metric scale on this acetylene regulator's low pressure gauge as well. In terms of operation, there are two basic types of compressed gas cylinder regulators: single stage, which reduces cylinder pressure in one step, and two stage, which reduces cylinder pressure in two steps. A single stage regulator is unable to compensate for the decrease in internal pressure as gas is drawn from the cylinder. When you use this type of regulator, you'll have to periodically regulate the output pressure with the pressure adjusting screw as the cylinder's gas is consumed. With a two-stage regulator, the first step is to reduce the pressure from the cylinder to a predetermined transitional pressure by opening the valve until the desired pressure is reached. The second step is to adjust the transitional pressure using the pressure adjusting screw. Then, the two-stage regulator can deliver gas at a constant pressure as the gas in the cylinder is being consumed. A flashback arrestor contains a flame-resistant filter that stops the flame from burning back into the regulator. The flame-resistant filter allows heat, but not flames, to pass through. Flashback arrestors and check valves can be attached to the torch handle connection, or to the outlet of the regulator, or they can be attached to both. Flashback arrestors have arrows on them that indicate the direction of the gas flow. When you install flashback arrestors on cylinders, be sure that the arrows match the gas flow direction. The check valve allows gas to move in one direction. If the gas tries to flow in the opposite direction, the valve closes to prevent the gas from flowing back into the cylinder. Check valves should be tested occasionally by attaching them to the oxygen hose and opening the cylinder valve to make sure that gas flows in the correct direction. Check valves have arrows on them that indicate the direction of the gas flow. When you install check valves on cylinders, be sure that the arrow matches the gas flow direction. Regulators are fragile and can be damaged easily. To prevent damage, be sure to follow these basic guidelines when you're handling regulators. Don't jar or shake the regulator. Install the correct regulator on the correct cylinder. Oxygen connections thread to the right, and acetylene connections thread to the left. Reversing the installation of oxygen and acetylene regulators could strip the threads. Use a cylinder wrench to install and remove regulators. The wrong wrench won't provide the proper leverage, and it could slip and damage the connector nut. Release the adjusting screw before turning the cylinder valve on and when welding operations are completed. This prevents damage to the regulator when the cylinder valve is opened and high-pressure gas is released. Never lubricate or calibrate regulators yourself. Likewise, do not attempt to repair a broken regulator yourself. Discontinue work if you think a regulator is defective and report the problem to a supervisor. The oxygen and acetylene used in oxy-fuel gas welding rigs are contained in cylinders. Valves on the cylinders are controlled by regulators and can be opened to release the gases. In this part, we'll look at different types of hoses that are used to carry gas from the regulator to the torch. We'll also look at some guidelines for handling these hoses. Typically, oxygen hoses are green with right-handed threads on their connections. Acetylene hoses are usually red with left-handed threads. To attach a hose with right-handed threads to the regulator and the torch, turn it to the right. To remove it, turn it to the left. To attach a hose with left-handed threads to the regulator and the torch, turn it to the left. To remove it, turn it to the right. Both oxygen and acetylene hoses are made from soft, flexible rubber. Without proper care, these hoses could easily be melted, cut, or tangled, or they could become brittle and crack. Pressure from the regulator to the torch can't be maintained with a damaged hose. If the gas escapes, it could create a fire hazard. Be sure to inspect hoses for damage and wear before you use them. If you find cuts, burns, cracks, or other damage, replace the hose. To avoid overextending the hoses, place cylinders as close to the work area as possible, but be sure that they are far enough away from flames, sparks, and molten metal to avoid melting or burning a hose. Don't place a hose under metal that's being cut. Falling metal could sever the hose. Make sure there are no kinks or twists in a hose that could restrict the gas flow. When you're installing or removing a hose, use a cylinder wrench. The incorrect wrench won't provide the proper leverage, and it could slip and damage the fittings. Never lubricate hose connections. Many lubricants contain oil and grease that can ignite and explode in the presence of oxygen. Store hoses in flat coils to prevent cracks and kinks. The oxygen and acetylene used in oxy-fuel gas welding rigs are contained in cylinders. Valves on the cylinders, controlled by regulators, open to release the gases. Hoses then carry the gases to the torch. Finally, the torch mixes the oxygen and acetylene for the flame. In this part, we'll look at welding and cutting torches and tips. Welding, brazing, and soldering applications use welding torches and tips. Cutting operations require cutting torches and tips. There are two types of welding torches: equal pressure and injection. Equal pressure torches and injection torches differ in the way that they mix oxygen and acetylene. Equal pressure torches have a single tube or chamber inside where oxygen and acetylene are mixed. As the gases enter the torch, the amount of gas flow is controlled by valves located near the hose connections at the base of the torch handle. Oxygen and acetylene enter the chamber at equal pressures and mix together. Then the gases exit through the tip or nozzle. Injection torches have two separate tubes inside instead of a single mixing chamber. Therefore, the gases are mixed in the tip. Oxygen enters the torch under high pressure and passes through a restriction called a venturi. This increase in velocity produced by the venturi enables the oxygen to draw the acetylene into its stream just before it enters the tip. The gases are then mixed in the tip just before they exit. There are some basic differences between welding torches and cutting torches. Welding torches have their tips set at an angle wider than 90 degrees from the handle. Generally, cutting torches have their tips set at exactly a 90-degree angle. Though cutting tips may be set at other angles, the precise 90-degree cutting tip angle is used most often because it lets the welder apply maximum heat to a specific area. Another basic difference between the two types of torches is in the handle. A cutting torch has a flat lever on its handle, called a cutting oxygen lever. Depressing the lever releases an oxygen blast to cut metal. There are two types of cutting torches: a one-piece cutting torch and a combination cutting torch. The one-piece cutting torch has oxygen and acetylene valves that allow the gases to enter the torch and flow into the tip to be mixed. The combination torch consists of a cutting torch attachment that screws onto a welding torch handle. The attachment has an additional oxygen valve to control the supply of gas to the flame and a cutting oxygen lever. Because there are many different welding and cutting jobs, there are different types of welding and cutting torch tips. Welding and cutting torch tips are generally classified by numbers relating to their thickness. There's no industry-wide standard torch tip scale, so manufacturers set up their own scales. A torch can be fitted with many different sizes of tips. Welding tips have a single orifice or opening through which the oxygen and acetylene feed the flame. Cutting tips have 4, 6, or 8 small preheating orifices that supply gas to the flame. Cutting tips also have one large orifice through which the oxygen blast exits the torch. Whenever you're handling or changing welding or cutting torch tips, there are some basic guidelines you should follow. Always allow tips to cool after use before you attempt to change them. Tips expand when they're hot, and the expansion locks them into place. Use tip cleaners or tip drills to clean the orifices without damaging the metal. Use fine sandpaper occasionally to remove buildup on the outside surface of the tip. In this topic, we looked at some common parts of oxy-fuel gas welding rigs. We looked at compressed gas cylinders, regulators, hoses, and torches. We also covered some basic guidelines for handling each part. Now try some practice questions. In this part, we'll look at how the components of an oxy-fuel gas welding rig can be assembled. The specific procedure used for assembly can vary from plant to plant. We'll look at a typical procedure, but you should check with a supervisor to see how it's done at your facility. Assembling an oxy-fuel gas welding rig can involve a number of hazards, so make sure you follow your facility's safety precautions as well. To prepare for the assembly, the welder in our example first stands to the side of the cylinder valves and opens them slightly, or cracks them, to expel dirt that might be lodged in the valves. He then removes any remaining dirt by wiping out the regulator connection with a lint-free rag. Next, the welder connects the oxygen regulator to the oxygen cylinder and tightens the connection. He repeats the procedure to install the acetylene regulator on the acetylene cylinder. After the regulators are attached, the welder installs flashback arresters with check valves inside them. In our example, he attaches the flashback arresters with check valves to the hose connections on both the oxygen and acetylene regulators. Some procedures call for installing flashback arresters and check valves on the torch handle connection in addition to or instead of the regulators. In either location, flashback arresters stop fires, and check valves allow for gas flow in only one direction. The next step is to connect the hoses to the regulators. Next, the welder attaches the oxygen and acetylene hoses to their appropriate connections on the torch body. Based on the thickness of the metal he's working with, the welder selects the proper sized tip recommended by the tip manufacturer, attaches it to the end of the torch, and tightens it in place. This tip has a special soft seat design that requires hand tightening only. Other tips may require tightening with a wrench. When all the rig parts are assembled, there are just a few more things the welder needs to do. First, he checks to make sure that the oxygen and acetylene valves on the torch are closed to prevent the release of the gases into the work area. Then, he loosens the adjusting screws on the oxygen and acetylene regulators to prevent damaging the regulators when the cylinder valves are opened and high-pressure gases are released. Next, he slowly opens the oxygen cylinder valve all the way so that the pressure in the gauge can rise gradually. Now the welder opens the acetylene valve just a half to 3/4 of a turn. The valve must be opened at least a half turn to deliver enough acetylene to the flame. Not having enough acetylene would restrict the gas flow to the torch and tip, causing them to overheat. Opening the valve no more than 3/4 of a turn enables the welder to close the valve quickly in case of fire. After the oxygen and acetylene valves are open, the welder adjusts the working pressure. He turns the oxygen regulator adjusting screw slowly until the working pressure is set to the manufacturer's specifications for the tip that he's using. Then, he repeats the procedure with the acetylene regulator. He uses the pressure adjusting screw to set the working pressure for the acetylene. Undetected gas leaks in the equipment could cause a fire or an explosion. The welder tests for leaks by brushing a non-oil-based detergent and water solution on possible leak points. He tests the oxygen cylinder valve, the acetylene cylinder valve, the oxygen regulator connection, the acetylene regulator connection, and the hose connections at the regulators and the torch. Bubbles will form like this if a leak is present. The welder can also check for leaks by closing the oxygen and acetylene cylinder valves after the working pressure has been set for both. If no change in pressure occurs, no leaks are present. A drop in the pressure gauge readings, however, indicates a leak. If the welder detects a leak, he'll report it to a supervisor. Otherwise, he'll continue with his welding assignment. In our example, no leaks were detected, and the welder is ready to proceed. Undetected gas leaks in the equipment could cause a fire or an explosion. The welder tests for leaks by brushing a non-oil-based detergent and water solution on possible leak points. He tests the oxygen cylinder valve, the acetylene cylinder valve, the oxygen regulator connection, the acetylene regulator connection, and the hose connections at the regulators and the torch. Bubbles will form like this if a leak is present. The welder can also check for leaks by closing the oxygen and acetylene cylinder valves after the working pressure has been set for both. If no change in pressure occurs, no leaks are present. A drop in the pressure gauge readings, however, indicates a leak. If the welder detects a leak, he'll report it to a supervisor. Otherwise, he'll continue with his welding assignment. To use a torch safely, you should be familiar with the flame and how to adjust it. In this part, we'll look at 3 different types of oxy-fueled torch flames, and we'll see a typical procedure for lighting a torch and adjusting the flame. The 3 types of flames that we'll look at are neutral flames, carburizing flames, and oxidizing flames. The 3 types of flames that we'll look at are neutral flames, carburizing flames, and oxidizing flames. A neutral flame burns equal parts of oxygen and acetylene. The inner cone of a neutral flame is light blue. It's surrounded by a darker blue outer flame envelope that results when oxygen in the air combines with the heated gases in the inner cone. A neutral flame burns equal parts of oxygen and acetylene. The inner cone of a neutral flame is light blue. It's surrounded by a darker blue outer flame envelope that results when oxygen in the air combines with the heated gases in the inner cone. A carburizing flame has a white streak or feather that is created by burning excess acetylene. The length of the feather depends on the amount of excess acetylene in the flame. A carburizing flame has a longer and brighter blue outer flame envelope than a neutral flame. A carburizing flame is cooler than a neutral flame. For this reason, it is not used for cutting applications. The third flame type is an oxidizing flame. An oxidizing flame has an excess of oxygen. Its inner cone is shorter, bluer in color, and more pointed than the inner cone of a neutral flame. Its short outer flame envelope often fans out at the ends. An oxidizing flame is the hottest of all gas flames. However, an excess in oxygen is detrimental to welding operations. Excess oxygen can combine with the base metal to form metal oxides, which will weaken and deteriorate the joint. For this reason, an oxidizing flame is rarely used. Lighting the torch is a fundamental part of using an oxy-fuel gas welding rig. However, there are variations in the procedures that are used, as well as a number of safety considerations to keep in mind. We'll look at a typical lighting procedure, but before you light a torch and adjust the flame, check with a supervisor to see how it's done at your facility. Be sure to follow the safety precautions for where you work as well. In our example, the welder's rig is assembled. He's wearing the required personal protective equipment, and he's ready to light the torch. To make sure that the oxygen hose contains only oxygen and that the acetylene hose contains only acetylene, the welder purges each hose. Purging is accomplished by opening the torch's oxygen and acetylene valves one at a time for 2 to 3 seconds for each 25 feet of hose. Once the hoses are purged, the welder opens the acetylene valve on the torch handle a half turn. He positions a friction lighter near the front of the torch tip and lights the torch. The friction lighter, which is also called a striker or a spark lighter, works by rubbing a piece of flint against a steel surface to create sparks. The torch is lit now, and the welder adjusts the acetylene flame by turning the acetylene valve on the torch body. He increases the acetylene until the flame stops smoking, which indicates that he has the proper mixture of oxygen and acetylene. Finally, the welder slowly turns the oxygen torch valve to open it and continues adjusting the valve until he has fine-tuned the flame to the type needed for his welding job. In this case, he needs a neutral flame to do a cutting job. In this part, we'll look at how to shut down and disassemble an oxy-fuel gas welding rig. The shutdown and disassembly procedure that we'll see may be different from the one you follow, so always check with your supervisor to make sure that you're clear on the procedure that's used at your facility. There are 2 basic steps to shutting off a torch. First, the welder in our example closes the acetylene valve on the torch body. Now he is ready for step 2, closing the torch's oxygen valve. The next step is to close the acetylene and oxygen cylinder valves. This stops the flow of gas from the cylinders so that the parts of the rig can be safely disassembled without releasing the gases into the air. After he closes the oxygen and acetylene cylinder valves, the welder reopens the oxygen valve on the torch. This allows the excess gas to escape so that it doesn't become trapped inside the torch or the hose. He makes sure that all of the excess gas is released. Releasing all the excess gas is important because it prevents a gas release from gas trapped in the torch or the hose. Such an uncontrolled release could be explosive. If all the excess gas is released, the oxygen working pressure gauge reads 0, and he closes the torch oxygen valve. Tension on the regulator adjusting screw can damage the regulator over time. To ease the tension, the welder backs out the oxygen regulator adjusting screw until it is slack. Now the welder repeats the same procedure for acetylene. Your facility may shut down acetylene first, then oxygen, so check with a supervisor. However, the procedure is generally performed start to finish for one gas before it's started on the other. Both cylinder valves closed and all pressure gauges at 0 indicate that an oxy-fuel gas welding rig is shut down. Now the welder disassembles the rig by basically reversing the assembly procedure, starting from the torch and working his way in. He removes the oxygen and acetylene hoses from the torch. He then removes both hoses from the regulators. And he removes the regulators from the cylinders. He should replace the protective caps on the cylinders next. The cylinder valves are the weakest point of the cylinder. The protective caps guard the cylinder valves against damage and breakage if the cylinder falls or is hit. Finally, the welder secures the cylinders upright and transports them to their separate storage areas. In this topic, we examined one way to assemble an oxy-fuel gas welding rig. We looked at different types of oxy-fuel flames and how to light a torch and adjust a flame. We also looked at how to shut down and disassemble an oxy-fuel gas welding rig. Now try some practice questions on this material.